Hey friends, welcome back to Hop into Precalculus. Today we're talking about end behavior, which means figuring out what a polynomial does as x gets really big or really small. We'll learn how to use the degree and leading coefficient to predict the shape of the graph at the edges without needing to graph the whole thing. Let's hop into it and break it down step by step. In this video, we're going to be talking about 1.6, polynomial functions and end behavior. So we're going to be talking about odd degree polynomials first. On the left, we have a odd degree polynomial with a positive leading coefficient. And in this example, it's x cubed. And we have the limit statements as x approaches infinity, f of x also approaches infinity. We can see here as x gets bigger, f of x also gets bigger, and it points up to infinity. And then the limit as x approaches negative infinity, f of x also approaches negative infinity, which means it points downwards. And then you can think about this in a different way. Let's say as x approaches infinity, you can say, let's say x is 1 million. And if you plug in 1 million to x cubed, you have 1 million cubed. So obviously it would become close to infinity. And then if you have x approaching negative infinity, it's negative 1 million cubed, and then that means you would get a very big negative number. On the right side here, we have an odd degree polynomial with a negative leading coefficient, negative x cubed. For this one, as the limit of x approaches infinity, f of x approaches negative infinity. Because as x gets bigger, f of x gets more negative and bigger. So it's towards negative infinity. And then when x approaches negative infinity this way, f of x approaches positive infinity and gets bigger. Again, we can think about this using really big numbers. So for as x approaches infinity, let's say it's 1 million. And then because it's negative x cubed, it's negative 1 million cubed, and that would end up being a really big negative number. But if you have negative infinity, negative 1 million cubed, and then you have the negative sign from the negative x cubed, then you'd end up with a really big positive number for the second limit statement. Now let's talk about even degree polynomials. On the right side, same as the first slide, is a positive leading coefficient. And then this one is the graph of x to the fourth power. So the limit as x approaches infinity, f of x also approaches infinity, because as x gets really big, f of x also gets really big. So it turns positive infinity. And then as x approaches negative infinity this way, f of x approaches infinity. So it also points up at infinity, positive infinity. And then again, we can test this out using numbers. A really big number close to 1 million, infinity would be 1 million. And 1 million to the fourth power would be a really, really big positive number. And negative 1 million to the fourth power would also be the same value as the normal 1 million to the fourth power, because for even powers, they're all positive. And then on the right side, we have a negative leading coefficient even degree polynomial, which is negative x to the fourth. Here we can see as x gets infinitely big this way, f of x gets really negative, so it points downward at negative infinity. Also, as x gets really big, like on the negative side, f of x gets really negative, so that's why it's also negative infinity. And using the 1 million again, if you have negative 1 million to the fourth power, it's going to be negative. And then if you have negative 1 million to the fourth power, it's also going to be negative and equal to the same thing as the other one. Time for some practice problems. We have two polynomials shown graphed on the coordinate plane, and we're going to write the limit statements for both of them. So let's look at the left one first. The limit as x approaches infinity, f of x equals, so we see as x gets really big, see f of x also gets really big, so it's infinity. Next, for the other side, limit as x approaches negative infinity, f of x equals, so we can see as x gets infinitely big on the negative side, f of x also gets infinitely big, so this also equals infinity. And then based on these limit statements, we can conclude that this graph is of an even degree polynomial. On the right side, let's do the same thing. Limit as x approaches infinity, f of x equals, so when x gets really big, f of x also gets really big, so it's infinity. And limit x approaches negative infinity, f of x, you can see as it gets negative infinitely big, it goes downwards, so it equals negative infinity. And then we can conclude that this is a graph of an odd degree polynomial with a positive leading coefficient. Now let's do some identification based on the equations. So for the first one, we can find the leading coefficient, which is a -1, and the degree is a 4. So that means it's going to be an even degree polynomial with a negative leading coefficient. And then that looks like, that has the end behavior pointing like this. And we can write the limit statements. And this is for the other side. And next we will look at the second question. And it may seem like this is the one with the leading coefficient and the degree, but it's actually this one because it's the highest. And this is a positive leading coefficient and odd degree polynomial. So that means it's going to look something like this. And we can write the limit statements again. And that's it for end behavior. Now you know how to look at a polynomial and know what it looks like. If this helped, don't forget to like, subscribe, and comment below with your favorite example, or ask me any questions if you're stuck. Thanks for hopping by, and I'll see you in the next one.